Let's talk about the normal distribution and probabilities associated with that. And we're going to use the empirical rule. So let's review what we've been talking about with discrete random variables. If we have a discrete random variable, the distribution of a discrete random variable, we may have something like this. And we can talk about the probability of each value of the discrete random variable. But if we have a continuous random variable, we might have the same numbers, but now we also have the probability and the possibility of all these other values occurring. So 2.1 and 3.5, all of these could occur instead of just 1, 2, or 3. So here we have the probabilities adding up to 1, but in this continuous continuous random variable, we have the area has to add up to 1 because the area represents the probabilities of all these infinite possibilities. When we look at another graph, and we can have -1, -2, 1, or 2. So this will be 1, and that's 0.5. What if we have values like this? And we can say that the probability of a 2 is 0.1. The probability of a 1 is 0.15. The probability of a 0 is 0.5. Then we have 0.15 and 0.1. So all of these probabilities need to add up to 1, which they do. 30 plus 20, 50. And we can talk about the probability that x equals 1. The probability is 0.15. And we can talk about the probability that x is greater than 0 but less than or equal to 2. So this is describing 1 or 2. And we would just say 0.15 plus 0.1, and we get 0.25. We can answer questions like that. If we have a continuous random variable that has infinite possibilities, now it doesn't make sense to say what's the probability that x equals 1, because there are infinite possibilities in any interval containing 1. So now that's we don't even consider that. Now we have to talk about only intervals of values. So here we could say what's the probability that x is between 0 and 2. And let's just think about the area under this curve. We know the area is 1, so if we divided it in half, we know the area is 0.5 and 0.5. And now if we're estimating this area here from 0 to 2, we may say that it's 0.49 because we have a little bit of area out here that we don't want, and so maybe we'll just say 0.49. With what we know now, that might be a good guess. But let's look at some more information about the area, the areas, and the normal distribution, and that's going to be using the empirical rule. So we have the mean is 0, and then we're going to go out multiples of the standard deviation. So we're going to go the mean plus 1 standard deviation, or 2 standard deviations, or 3 standard deviations. We could go down 1 standard deviation, or down 2 standard deviations. So standard deviations are, the further we get away, we have the lower probability of being that far away from the mean. And the empirical rule tells us that this area is approximately 0.68. And then if we went 2 standard deviations away, that area, all of this area, is 0.95. And if we go 3 standard deviations away, that's going to be 0.997. When we talk about this, we don't use, well, we do use standard deviations, but we also call these z-scores. And we could remember z associated with 0. So if the mean is 0 and the standard deviation is 1, we can talk about z-scores like this. So let's look at, we do need to know the numbers in each of these parts for the types of questions that we're going to get. So then, when we write it like this, these are standard deviations, but they're also z-scores, z-score of 1. And now let's look at all of the regions in here. That'll help us answer some questions with the empirical rule. So we know that 0.68 is between -1 and +1 standard deviations. So that means this would be 0.34 on each of those. If we go up here to 0.95 and subtract 0.68 and then divide by 2, we know that this leftover part will be 0.135. And then we could do this. Let's find out these between 2 and 3. So that would be 0.997 minus 0.95, and then divide by 2. 0.0235. And we could then look back up here and do 1 minus 0.997. So from -3 to 3 is 0.997, and we're going to go 1 minus that and then divide by 2 to see the area of each tail, and that's going to be 0.0015 in each tail. Now these numbers are areas, and they correspond to probabilities of values in this interval occurring. So what's the probability of a variable having the value from 0 to 1? It's 0.34. And we can just look at these values to answer questions about probability. Find the probability that z is between -1 and 1. Every time you have a question about the normal distribution, you should always redraw the graph and shade the part that you want. Also, when z is used, z means that the mean is 0 and the standard deviation is 1. If x is used, then these will be different. All right. So let's always draw. The mean is 0. We're going to go from -1 to 1, shade the region that we want, and then we can have to think about 1 standard deviation up, 1 standard deviation down. We know that's going to be 0.68. So the probability that -1 is less than z is less than 1 is 0.68, approximately 0.68. By the empirical rule, it is 0.68. Find the probability that 0 is less than z is less than 1. Pause the video and try that on your own. Always draw the distribution. We're going from 0 to 1. So then we think back to the empirical rule, which says that -1 to 1 is 0.68. So we can say that from 0 to 1 is going to be 0.34. And pause the video, try that one. All right, between 1 and 2, we need to find that area. So we could calculate it, or if we just keep using these numbers between 1 and 2, we know that the area under the curve between 1 and 2 is 0.135. So we know that the probability that z is between 1 and 2 is 0.135. Find the probability that z is greater than 2. Pause the video and try that one. So we know we want that part of the graph, and we could just look for the values that we've found. It's greater than 2, so it's going to be this plus that. The probability that z is greater than 2 is going to be 0.0235 plus 0.0015, and we get 0.025. And find the probability that z is less than -1. Pause the video and try that. Less than -1, so we want everything to the left. That means we're going to have to find, there are other ways to do it, but if we just looked at the numbers that we found, we can just add up those three numbers. So we can look back here to the left of -1, 0.135, 0.0235, 0.0015. The probability that z is less than -1 is 0.135, 0.0235, 0.0015, and we get 0.16. So that's how we can use the empirical rule to estimate probabilities without using a calculator. Now let's see how the calculator is used. Let's find the probability that z is less than 1 using a calculator. Even though we're using a calculator, let's make sure we visualize it. We're going to the left of 1. We want the area of all of that. So in the calculator, it is second vars, normal CDF. We don't use PDF, we'll just use CDF. Now, the graph goes on to negative infinity, so we can just pick some number, and here the calculators give me this negative number way to the left. You could use that number, or you could just use negative 100. It would still give you the same answer. The upper bound is 1. We're going to go up to 1. The mean is 0. Standard deviation is 1. So because we have a z variable, we know it's the mean 0, standard deviation of 1. And then if your calculator has this display, then you have to know that that's going to be left bound, right bound, mean, standard deviation, and then it gives us the probability. So the probability that z is less than 1 is 0.8413. Alright, probability that z is less than 0.88 using a calculator. So draw the graph and use a calculator. Try that one. .88, somewhere over here. We're going to be to the left. And then in the calculator, it would be normal CDF, left bound. You could do negative 1,000 or whatever. Negative 10 would probably give you the same answer. It goes from the left to 0.88 with a mean of 0, a standard deviation of 1. So if we do that on the calculator, we get 0.81057. All right. And we can just finish with these two. So do these two on the calculator, and then we'll be done. Negative 1.53. Well, we know it's over there. Negative 1.53. Z is greater than that, so we want that area. And then on the calculator, normal CDF, we need the lower bound, negative 1.53. Upper bound, you could just choose 1,000. Mean 0, standard deviation of 1, and we should get 0.9370. From 1.7 to 2.5, we're looking for that area, and that'll be the probability of z having a value between 1.7 and 2.5. So on the calculator, we go from 1.7 to 2.5 with a mean of 0, standard deviation of 1, and that should be 0.0384. We'll stop there.